Hi everyone, welcome to lesson 1-3, which is all about operations with decimals. Take a moment to look in the Google Classroom to locate these documents and print them out. You can also grab colored pens if you'd like to take color-coded notes along with me. Otherwise, a pencil will suffice. And then press play when you're ready to begin our lesson. Thank you for grabbing all of the materials. And once again, welcome to lesson 1-3, which is about operations with decimals. The objective for today's lesson is that you should be able to add, subtract, multiply, and divide decimals with 90% accuracy without using a calculator. So let's take a dive into the meat of our lesson. The first portion of our lesson will review how to add and subtract decimals. The first thing that we'll review are the rules. When you add or subtract decimals, it is important to line up the decimals by place value. It's also handy to remember that you can add an unlimited number of zeros to the end of a decimal in order to make adding them easier. Now let's practice these steps by completing the 4 examples to the right. As you recall from lesson 1-1, I'm going to circle the number and the sign that's immediately in front of it. I'm placing the sign of the number above the circle. I'm doing this so that way I can clearly identify if the signs on the numbers are the same or if they're different. You can recall that from lesson 1-1, if the signs are the same, then I can add the numbers and keep the sign. If the signs are different, then I'll have to subtract the numbers and keep the sign of the number with the larger absolute value. As I'm modeling for you here, I'm using the grid to assist me in maintaining the numbers in the correct place value location. I'm going to start by writing 854 hundredths in the top row because this is the larger number. Notice that I've written the next decimal point directly below the first one. This is to ensure that I write 91 and 5/10 in the correct place value locations. For your convenience, and in case you needed a reminder, the decimal place value chart is in the lower right-hand corner of your screen. So to continue with our example, remember that because we have the same signs, we're able to add the numbers together. If you're looking at how I've placed the numbers in this grid, you'll notice that there's no number beneath the 4. I can choose to leave this space blank. However, some folks prefer to place an imaginary 0 in order to ensure that all their place values are correctly lined up. As our note says, you can add an unlimited amount of zeros to the end of a decimal in order to make the adding easier. Therefore, if I add a 0 to 91 and 5/10, it does not change the value. I apologize that we missed a clip here, but as you can see, I added the numbers together and we came up with a sum of 892 and 4 hundredths. In this next image, I began the second example by circling the number and the sign that's immediately in front. You'll notice that 921 and 7/10 is a positive number and 3 and 9/10 is a negative number. Because the signs are different, we'll need to subtract our numbers and keep the sign of the number with the larger absolute value. I'll begin by placing the larger number in our grid first. I'm going to write 921 and 7/10. Then I'm going to write 3 and 9/10 below it, making sure to line up the correct place values. Again, as a reminder, because our signs are different, we will need to go through and subtract. When I subtract 921 and 7/10 from 3 and 9/10, I end up with a difference of 917 and 8/10. Here you could just see me subtracting manually and placing a box around my final answer. Let's move on to our next example. As usual, I'm going to look to circle the number with the sign that's immediately in front. However, before I do that, I noticed a red flag or something that stands out to me. I see that there are double negatives, or in other words, two negative signs right next to each other. As you recall from lesson 1-2, if I have double negatives, or in other words, two negative signs next to each other, that indicates multiplication, and a negative times a negative gives me a positive. So remember that double negatives become a positive sign. So if I'm circling the number and the sign that's immediately in front, then 10 and 84 hundredths will be considered positive, and negative 7 and 6,783 ten thousandths is considered to be a negative number. Now that I've clearly identified that I have a positive number and a negative number, I know that I'll have to subtract the numbers and keep the sign of the number with the larger absolute value. I'll begin by writing the larger of the two numbers down first. So the larger number is 10 and 84 hundredths. Again, I'm placing each number in a box, and the grid is assisting me in lining up my decimal places. Then I'm going to write the next number immediately below the first one and making sure to line up the decimal points so that my numbers are lined up in the correct place value locations as well. And again, remember that we are subtracting. Notice that negative 7 and 6,783 ten thousandths has more decimal places than 10 and 84 hundredths. In order for me to be able to subtract these numbers, I'll need to add 2 zeros behind 10 and 84 hundredths. You'll recall our note that you can add an unlimited number of zeros to the end of a decimal in order to make adding or subtracting easier. Now that I've added these zeros, I can go through and subtract my numbers, and I'll end up with a difference of 3 and 1,617 ten thousandths as my final answer. In order for you to see the next question, I have moved the place value chart to the top of your screen. Now let's do our last addition and subtraction of decimals example. As usual, I'm going to go in and first circle the number and the sign that's immediately in front of it, so that way I can clearly recognize what signs my numbers are that I'm working with. Again, I apologize for the glitchiness of this video. My computer lost some of the footage in between. The first number and sign I'll circle is that of negative 26 and 786 thousandths. And then I'll circle negative 13 and 2 tenths. Being that both numbers are negative, I know that I can add the numbers together and keep my signs. You'll notice that I placed them in the grid and making sure to line up the decimal places as well as the decimal points. And now you see me going through and adding the numbers together. And I'll come up with a sum of negative 39 and 986 thousandths. And I'm placing a box around my final answer. Now that we've completed our examples on how to add and subtract decimals, let's take a look at how we multiply decimals. When multiplying decimals, the decimal points do not have to line up. So, how do you multiply? You'll multiply as normal. But when you're determining the final answer, you must replace the decimal point in your product. So to do this, you're going to count the total number of decimal places in the factors and place the same amount of decimal places in your product. So there are some vocab terms in there that you might not remember or be familiar with. So the term factors came up. Factors are the two or more numbers that are being multiplied. So I'm going to circle that and write that definition off to the side for you to refer to. And then the term product is one that you should know, but just in case you don't, a product is an answer to a multiplication problem. So again, I apologize of losing the footage in between or the camera glitching, but as you can see here, we've placed 1 and 2/10 above 1600s, and the decimals do not line up in this case, and that is not a problem when you're multiplying. And then I'm going through and I'm multiplying by hand. You'll see that we came up with a product of 192, and then we needed to replace the decimal in our final answer. So in 1 and 2/10, there is 1 decimal place. To count the total number of decimal places in our factors, you'll notice that I have a loop. So there's 1 loop underneath the 2 in our factor of 1 and 2/10, so that's 1 decimal place. I then have 2 decimal places in the 1600s. Notice that there's 2 loops in that factor. Altogether, there's a total of 3 decimal places in our factors. So in order to complete the product, I'll need to replace those 3 decimal places in our final answer. To do so, I'll start on the right-hand side of the number, and then I'll count in 3 decimal places, hence the 3 loops that you're seeing underneath the 192. When I've replaced it, I'll have an answer of 192 thousandths, and I've placed a box around my final answer. Let's go ahead and do the next one together. Alright, so for our next one, we have 12 and 7/10 being multiplied by -2 and 3/10. So again, it does not matter if the decimals line up, and we're going to go through and multiply by hand, and we'll have a product of -29 and 21/100. There was a total of 2 decimal places in our factors, so you'll notice that I replaced those 2 decimal places in our product and placed a box around our final answer. And you'll recall from lesson 1-2 that a negative times a positive will give us a negative answer. So therefore our product is -29 and 21/100. And now to move on to the last example in multiplying decimals. In our last example, we are going to multiply -768 thousandths by -1 and 23/100. We aren't concerned about the decimals lining up because, again, this is multiplication. And then you'll see that I went through and multiplied by hand and came out with a product of 94,464 millionths as our decimal. In our first factor of -768 thousandths, there are 3 decimal places. In our second factor of -1 and 23/100, there are 2 decimal places. So altogether in our factors, we have a total of 5 decimal places that we'll have to implement into our product. Hence, this is why you'll see 5 loops starting from the right going towards our left, and that is why we end up with a product of 94,464 millionths. Alright, y'all, so some footage got lost here as well, and again, I sincerely apologize. I'll go in and re-record this and re-upload it for you. However, for now, we're going to go ahead and go through our dividing decimals section of our notes. So the first thing to keep in mind is that when you're working with decimals and division, you're going to want to move the decimal points enough times into the right to make the divisor a whole number. The divisor is the number that's sitting on the outside of our division symbol. The same number of times that you move it in the divisor is the same number of times that you need to move it in the dividend as well. And the dividend is the number that sits underneath our division symbol. The second thing that you'll do is rewrite the division statement with the whole numbers instead of the decimals. And then before you start dividing, you're going to carry your decimal point going straight up. So for our first example, you'll notice that we're dividing 7/10 into 3 and 1/100. As you know, 7/10 is a decimal with 1 decimal place. Therefore, in order for me to make this a whole number, I will need to move the decimal point 1 time to the right. When I move it 1 time to the right, instead of 7/10, this will now become the number 7. I will need to move the decimal point an equal number of times in the dividend. So I'm going to move my decimal place 1 space to the right in the dividend as well. So now instead of 3 and 1/100, I'm going to have 30 and 1/10. I've rewritten the division statement to reflect the whole numbers as well. So essentially what I did was I multiplied the dividend and the divisor by 10. Since the problem is set up this way, I'll then go through and do long division. So now my problem is 7 dividing into 30 and 1/10. As you know, 7 cannot divide into 3. However, 7 can divide into 30. 7 goes into 30 4 times. So I'm going to write 4 above my division symbol. And 7 times 4 is 28. So I'm going to subtract 28 from 30. That leaves me with 2. 7 cannot divide into 2, so I'm going to carry down the 1. 7 can divide into 21. 7 goes into 21 3 times, and that leaves me with a remainder of 0. So my quotient for this problem is 4 and 3/10. 7/10 divides into 3 and 100, 4 and 3/10 times. All right, let's take a look at our last example. In our last example, we are dividing 5 and 4/10 into 11 and 88/100. Again, in order for us to divide, we need to change the divisor from a decimal to a whole number. Since the divisor only has 1 decimal place, we are going to move that decimal 1 spot to the right. And since I'm moving the decimal point 1 spot to the right in the divisor, I'm also going to move the decimal point 1 spot to the right in the dividend and rewrite our problem. So now our problem will be rewritten as 54 dividing into 118 and 8/10. 54 cannot divide into 1. 54 cannot divide into 11. However, 54 can divide into 118. 54 goes into 118 2 times. And 54 times 2 gives us 108. When I subtract, I'm left with a difference of 10. 54 cannot divide into 10. So therefore, I have to carry down our last 8. 54 can divide into 108, and it does so 2 times. And 54 times 2 is 108, which leaves me with a remainder of 0. So our quotient for this problem is 2 and 2/10. So in other words, what we can say is 5 and 4/10 divides into 11 and 88/100 2 and 2/10 times. Alright guys, so that brings us to the end of our lesson, and I've just zoomed out here so that way you can see what your notes should look like. Again, remember that it is best if you're taking the notes along with me throughout this video, so that way you are interacting with the material and you're able to retain it better for a much longer time. Alright, now that you have your notes done, what you are responsible for completing is the student page, and you will see that posted in the Google Classroom, and it looks like this. Please try and do this without a calculator, and then if needs be, you can go ahead and check your solutions afterwards. And this is going to be due in the Google Classroom at 11:59 p.m. tonight. Alright guys, thank you so much for hanging with me and going through lesson 1-3. If you have any questions on this lesson, please feel free to leave your questions either on the lesson itself, or you can leave your questions in our Unit 1 Padlet parking lot of questions. Thank you so much, guys. Can't wait to see you guys tomorrow. Thanks for watching. Bye.